Today, we're digging into a new paper that basically flips a common AI trick on its head. It's all about teaching a model a powerful new skill, how to find the right answer, even when it's hiding in a crowd of wrong ones.
So, you probably know the drill. To get a better answer from an AI, a popular method is to have it generate, say, a dozen different solutions, and then you just pick the one that shows up the most. It's called self-consistency, and yeah, it works pretty well. But it's all built on one shaky assumption, that the most popular answer is the correct one. So what happens when the crowd is confidently, overwhelmingly wrong?
Well, you get what you could call the tyranny of the majority in AI. See, simple voting is quick and easy, but it has a massive blind spot. If a model has a common, subtle misunderstanding, majority voting acts like an echo chamber. It amplifies that one mistake, confidently picks the wrong answer, and completely ignores a correct but lonely solution in the corner. Plus, it throws away the chance to stitch together a perfect answer from the partially correct bits of several different attempts.
And that's where this paper comes in with a really clever solution called AggLM. The idea is, instead of just teaching an AI to count votes, let's teach it a whole new reasoning skill, how to actually aggregate different ideas into a single, much better one.
Okay, so let's really break this down. AggLM changes aggregation from just a simple counting trick into a genuine learned skill. The model isn't just a voter anymore. It's more like a sharp-eyed editor. It learns to read a bunch of different drafts, spot the brilliant ideas in one, see the sloppy mistakes in another, and then synthesize a completely new and correct final report that's way better than any of the originals.
You know, the language the authors use in the paper is super telling. They use words like review, reconcile, and synthesize. This isn't just about tallying up frequencies. This signals a move towards deep reasoning, actually understanding the logic in different paths and intelligently weaving them together.
So how does this actually work? It's basically a four-step process. First, you have your base model generate a bunch of different answers. Then, you feed all those answers to the special AggLM model. It does its synthesis magic, and this is the crucial part, it gets a super simple reward. A 1 if the final answer is right, and a 0 if it's wrong. That's it. Over time, this simple feedback loop trains the model to become an expert at this synthesis task.
So, that's the theory. It sounds great, but the million-dollar question is, does it actually work any better than the old methods? All right, let's take a look at the data.
And the performance jump is, well, it's pretty darn clear, especially on this AIME 25 math dataset. And just so you know, these are really tough high school math Olympiad problems. The base model alone gets about 36% right. Standard majority voting gives it a nice bump to almost 46%, but look at AggLM. It pushes the accuracy all the way to 50%.
We're talking a more than a 14-point absolute improvement over the original model. And get this isn't from making the model bigger or stuffing it with more training data. This jump comes purely from teaching it how to intelligently combine its own ideas.
And this wasn't a fluke. Across a whole bunch of really hard math benchmarks, AggLM, which is a pretty small 1.7 billion parameter model, consistently takes the top spot. Here's the kicker. It even beats massive 72 billion parameter reward models that were specifically designed to just pick the best answer from a list. It turns out, synthesizing is just better than selecting.
So why is this thing so darn effective? What's the secret sauce? Well, it's not just that final reinforcement learning step. A huge part of the magic is actually in the kind of examples the model was trained on. The researchers discovered this kind of Goldilocks zone. You might think just training it on the hardest problems would be best, but nope. And surprisingly, training it on all the data wasn't the answer either. It actually diluted the effect. The key was a carefully balanced mix of easy and hard examples. That's what got them to that peak 50% performance. So what makes an example hard? According to the paper, a hard case is one where most of the initial answers are just plain wrong. This forces the model to learn how to be skeptical, to ignore the crowd, and to hunt for that correct minority opinion. The easy examples, where the majority is right, teach it when it's okay to trust the consensus. It's that balance that makes it so smart.
And this chart really shows you when AggLM is the MVP. It provides the most value when things are messy, when the initial answers are all over the place and there's no clear winner. In those moments of high uncertainty, its ability to reason is a huge advantage. But what if the problem is easy and almost all the answers agree? It's smart enough to just go with the flow, performing just as well as simple voting.
Okay, so it's more accurate, which is awesome. But for any developer out there, there's another huge factor: compute cost and efficiency. And believe me, this is where things get really, really interesting.
This is honestly one of the wildest results in the whole paper. The data shows that using AggLM to combine just 8 solutions gets you a better result than taking the majority vote of 16 solutions. Just let that sink in for a second. You get higher accuracy with literally half the upfront work. And when you look at the tokens, which, let's be honest, translates directly to dollars, the savings are huge. The aggregator model uses about 1/3 of the tokens it takes to generate a full solution from scratch, which makes sense, right? It's not writing a novel from a blank page. It's just editing a few drafts. It's way more efficient.
So the bottom line here is incredibly simple. You get a smarter answer, and it costs you less to get there. For anyone actually building products with this stuff, that is a powerful, powerful combination.
All right, so let's boil all of this down. If you're a developer or a researcher, what are the key things you should be taking away from this work?
I think it comes down to 3 big things. First, challenge the majority. Don't just blindly trust the most common answer. It's a good baseline, but it can break. Second, start thinking about how you can teach a model a reasoning skill, like synthesis, instead of just using it to pick from a list. And third, remember that efficiency is a feature. Getting a better result for less compute is a total game changer.
Now, before we all get too carried away, there is one pretty big catch to keep in mind. This whole reinforcement learning setup works beautifully because, with things like math, an answer is either 100% right or 100% wrong. It's easy to verify. But just imagine trying to apply this to something subjective, like judging the quality of a story or a poem. How do you give it a simple 1 or 0? That's a much, much harder problem to solve.
And that really leaves us with a fascinating thought for the future. I mean, think about the evolution here. We went from an AI giving us one shot at an answer to giving us many shots so we could pick the best one. Now, this paper shows we can synthesize an even better answer from all of them. So, what's the next logical step? It feels like it has to be true collaboration, right? Where AIs don't just refine, but actually work together to discover things none of them could have found alone. And that just opens up a whole new world of possibilities.